visor drops. Music swells behind one long, deliberate breath in the silence. An astronaut stands motionless at the airlock boots locked and gloves fully sealed, face set in quiet resolve exactly the way movies always frame it. Every single latch clicks shut with real cinematic weight and precision. The camera lingers on that helmet before the hatch finally opens wide onto raw starlight. This is the version everyone already knows by heart. Behind that visor sits a different truth. Every single astronaut wears a giant diaper. That's the real story. Spacewalks have happened routinely since the 1960s, filmed and broadcast worldwide every time. Networks cut to slow-motion suit-up footage before nearly every major mission. Documentaries repeat that same reverent framing, decade after decade without fail. Nobody in any of that footage mentions what happens underneath the suit. Not once. The gap between the footage and the full story has lasted just as long. A gap that long. Nobody ever closed it, until now. Journalists covering early shuttle missions rarely asked about this topic directly. Not their job, apparently. Public relations teams steered interviews toward technical achievements instead of bodily logistics. That careful framing shaped decades of public perception around what a real spacewalk involves. Recent openness from agencies and astronauts has slowly started shifting that old habit. The full picture is finally entering public conversation, decades of silence. Slowly ending now. About time. Real footage from any suit-up shows a completely different order of events, not what the movies show at all. The pressure garment actually goes on last, not first. Cooling tubes and the rigid torso shell comes somewhere in the middle of the process, before any of that one small garment slides on first. It's officially called a maximum absorbency garment, worn directly against bare skin as underwear. Every astronaut on every EVA-capable mission since the Shuttle program has worn one. No exceptions. First on, last off, every single time. The garment traces back to earlier Apollo-era engineering problems on the ground. Crude solutions barely worked at all in those early years. Engineers redesigned the entire system repeatedly through the Shuttle era, refining absorption and comfort together. NASA now treats the MAG as standard hardware tracked like any other mission part. The design goal was simple, survivable, and completely unremarkable. Nothing more complicated than that. Decades of redesign for one small garment. Nobody ever notices it works. A MAG isn't just a pad taped inside underwear. It's actually engineered with real precision. Several thin absorbent layers wick fluid away from the skin almost instantly on contact. At the center sits sodium polyacrylate, a superabsorbent polymer. That specific polymer locks away roughly 400 times its own weight in liquid. A single garment holds close to 2 full liters of fluid without leaking under pressure. It stays reliable for 8 to 10 hours, no changing station needed. Not glamorous. Just engineered. Built to actually work. Sodium polyacrylate isn't exotic chemistry invented specifically for spaceflight. It's actually quite ordinary. That exact same polymer shows up in consumer diapers sold at any grocery store. NASA simply borrowed existing absorbent technology instead of building something entirely new from scratch. That choice made the MAG cheaper to build and simpler to trust under pressure. Sometimes the best engineering solution is already sitting on a shelf somewhere ordinary. Not invented, just borrowed, then improved. Step back and look at what that garment actually sits inside, a whole spacecraft essentially. The suit itself, formally the extravehicular mobility unit, is basically a one-person spacecraft. A rigid fiberglass torso locks around the entire chest like armor plating. Roughly a dozen layered fabrics wrap the limbs tightly for pressure and impact protection. A backpack feeds fresh oxygen in and scrubs carbon dioxide out continuously. Nearly 100 meters of water-cooled tubing pressed directly against the skin underneath everything. Vacuum carries no air to pull heat away, so that tubing does the job instead. One suit, zero air outside. A body needs backup for everything. NASA's spacewalk suits weigh close to 300 pounds fully assembled on Earth. Orbit erases most of that. Moving inside a fully pressurized suit still takes real physical effort against stiff fabric joints. Every finger fights internal pressure just to bend it all. An 8-hour spacewalk leaves astronauts genuinely exhausted by the time they're back inside. Exhausting work, the whole time, diaper included. Once that helmet seals and the suit pressurizes, the astronaut is sealed in for hours. Typical spacewalks run 6 to 8 hours from start to finish. The record stands at 8 hours and 56 minutes, an entire long workday spent in vacuum without a single break. Getting back inside early isn't ever a quick trip to any nearby bathroom. Depressurizing, floating back through the airlock, and repressurizing all takes real time on its own. Aborting mid-task risks the satellite and the entire mission. No pause button exists for basic biology. No break, no door. The suit is the whole world. Food and water inside the suit come through small tubes near the helmet. A drink bag holds roughly 1 liter sipped slowly through a straw during the task. Some astronauts even pack a small snack bar taped inside the suit for longer excursions. None of that changes what happens in the other direction, though. Input keeps flowing in through one tube. Output handles itself elsewhere quietly the entire time. Food goes in, waste goes out. Neither one waits. Suit failures during an EVA are rare. Training accounts for them anyway. Every astronaut rehearses these emergency return procedures long before ever reaching orbit. A leaking glove or a stuck valve demands an immediate calm response. None of those protocols involve pausing for basic bodily needs. The MAG removes one entire category of risk from an already crowded list. One less emergency. One quiet fix. Nobody thanks it. Picture the exact moment tension peaks during a real orbital repair. Gloved hands steady a multi-million-dollar instrument inches from failure. Mission control watches closely through a helmet camera holding its breath along with everyone else. Biology doesn't care how good the footage looks. An astronaut may simply relieve themselves right then mid-task without missing a beat. The MAG has already been doing its quiet job the entire time. Nobody on the ground ever even notices because nothing visible about the repair changes. Rehearsing happens mid-repair. Biology happens mid-repair too, both happening at once. This isn't a rare, embarrassing exception buried in one mission's files somewhere. It's the unbroken standard across the entire history of spacewalking itself. American astronauts always wear it. Russian cosmonauts always wear it. Chinese taikonauts wear it too, across every single one of those agencies' missions. Gender changes nothing about the requirement, and neither does rank or experience. Every human who has ever stepped outside a spacecraft has worn one of these. Universal, not exceptional. That's the whole point. Russian Orlan suits use a rear entry hatch instead of separate glove and boot seals, a completely different design philosophy altogether. Chinese Feitian suits borrow loosely from earlier American models too. Every single version still requires hours of continuous pressurized isolation regardless. No engineering tradition anywhere has ever solved the underlying problem differently. The MAG remains the one universal answer no matter which flag sits on the shoulder. Different suits, same solution, every single time. Female astronauts wear the exact same MAG design as their male colleagues. No difference at all. Early suit engineering assumed an entirely male body causing real problems elsewhere in the equipment. The MAG itself required almost no redesign at all to fit every astronaut equally well. Absorbent capacity and overall fit work the same way no matter who's wearing it. It remains one of the few suit components that never needed a gendered version. One design, every body. No adjustments needed. Commercial spaceflight companies now design their own suits for private astronaut missions. Same exact problem every time. Every one of those newer designs still includes some version of an absorbent undergarment. Nobody building a brand new suit from scratch has ever tried skipping this component. Engineers working at competing companies arrived at that exact same conclusion, completely independently. The underlying problem simply doesn't change no matter who's writing the specifications. Different companies, same conclusion, every time. Retired astronauts now discuss this openly in interviews and public talks. No hesitation left anymore. One veteran NASA engineer put it bluntly during a recent interview about suit design. For missions stretching 8 to 15 hours, the garment simply becomes routine equipment. Younger astronauts entering the program hear about it early without any embarrassment attached. The old silence around this topic has mostly disappeared from professional conversation now. Astronauts talk about it, openly now, just not on screen. Astronauts describe the psychological adjustment as harder than the physical one. Not easier at all, surprisingly. Wearing a diaper as an adult carries a different weight than any physical inconvenience. Training programs now include direct conversations about this exact discomfort before anyone ever suits up. Normalizing it early removes most of the hesitation astronauts report feeling initially. By the third spacewalk, most astronauts describe barely thinking about it at all. Strange at first, normal by the third time. That's how it goes. Ground simulations rehearse full EVA timelines inside giant swimming pools years before launch, years of preparation for a single afternoon outside. Astronauts practice wearing the actual mag during these pool sessions too, not just the suit. Neutral buoyancy tanks recreate weightlessness closely enough for genuinely realistic full-duration testing. Trainers track fluid intake and total duration carefully, making sure the garment performs as expected. By launch day, using it feels as routine as checking a helmet seal, practiced for years, before it ever matters. That's simply how routine it becomes. A marathon runner trains for months and crosses the finish line looking flawless. Crowds cheer, and every stride looks like pure discipline in motion. Underneath that performance, plenty of elite runners wear absorbent gear during the race itself. Stopping at a bathroom mid-race simply isn't an option when every second counts. A spacesuit works exactly the same way, scaled up for a much longer shift. The heroism is completely real. So is the plumbing underneath it. Both things are true, at once, always. This suit survives vacuum radiation and temperature swings past 250 degrees. It represents decades of the most advanced engineering ever built for a single human body. And it still starts with the same basic problem every parent solves for a newborn. What happens when the body simply can't wait for a convenient moment? Nobody scripted that part for the highlight reel. Yet it's there on every single mission regardless of who happens to be watching. The suit is heroic. The diaper is honest. Both make it genuinely human.